Welcome to part 6 of the guitar shaped pick tray series. Today we're going to finish operation 1. We're going to perform a 2D contour and finish our outside edges, and then we are going to break the sharp edges on the top of the model using a chamfering toolpath. Alright, let's go ahead and create our 2D contour toolpath. So we'll go to 2D, and in the drop down menu we'll select 2D contour. Now we'll select our tool. So we're going to select the same tool from our previous operation, which is the 3 flute 1/4 inch end mill from Char Tools. So I'll select OK. For the speeds and feeds, we're running at 8,000 RPM, 30 inches a minute, which gives us 1.25 thou per tooth for our feed per tooth. We'll go to the geometry tab, and we need to select the outside contour of our pick tray, and you'll notice there is an issue. So our arrow is pointing at the inside of this contour. So if we left it like this, we would actually come down and crash into our wall. We want to be finishing the outside of our contour. So I'm just going to click that arrow, and there you go. Now we're on the outside, and that will perform the toolpath that we want. The next thing I am going to do is go to our heights tab, and again, in our first tutorial we removed the 50 thousandths worth of stock above our model, so all of our top heights can be set to model top, and our bottom height is selected contour, which is what we want it to be, so that's fine. We'll now get into our passes tab. The first thing I want to change is I want to change the compensation type. So if we leave it as in computer, Fusion 360 will calculate the toolpath for us using that fixed 1/4 inch diameter. However, I want to choose wear. If I choose wear, it allows me to specify a wear offset as in my tool diameter column in Path Pilot, and what that does is if your contour is a little off, you can adjust by a few thousandths and really walk in a part to tolerance. So we want to have that option enabled. The next thing I want to do is enable finish overlap. So I want to put about 50 thousandths. And so what this does is when our tool comes into the toolpath, there's a chance that we might leave a little stock or an edge or a little imperfection there. So what a finishing overlap does is it allows us to overlap that entry point. So if there is a little stock left, we could clean up that imperfection. The next thing I'm going to do is enable smoothing, so that will clean up some of the line segments in our G code, and enable feed optimization. So Fusion 360 will take into consideration the kinematics. If we're making any type of sharp turns or quick transition, Fusion 360 will help slow down the machine and really reduce any sort of finish imperfections that we may get. Alright, the next thing I'm going to do is I'm going to go to the linking tab, and instead of a lead-in sweep angle of 90 degrees, I prefer 45 degrees. In my opinion, it is just a slightly smoother entry. So let me go ahead and hover over that so you can see. Alright, so that does it for the 2D contour toolpath. So I'm just going to click OK. And I'll right click and simulate. We'll slow it down just a hair. It's a rather quick toolpath, so I want to make sure we don't miss it. That's maybe a little too slow, so we'll speed it up a little bit. There we go. So we just led into our toolpath and then just did a quick contour around the outside wall, and that is our finishing pass. Now we will finish up operation 1 with a 2D chamfer toolpath that will break the sharp edges that could have formed on our sidewalls from the previous operations. So to do that, we'll go up to 2D, go to the drop down menu, and select 2D chamfer. We'll then go ahead and select our tool, which is in my Tormach library again, and we are going to use a 1/4 inch chamfer mill. So I'm going to go ahead and select that, select OK. And so it's 90 degrees or 45 degrees on each side of the point. For the speeds and feeds, I'm running at 4,000 RPM, nice and slow at 20 inches per minute, and that gives me around 1.25 thou per tooth. I'm going to go into the geometry tab, and we're going to select the outside and the inside of the sidewalls. We want to clean up any burrs or sharp edges on both sides of the wall. We're then going to go to the heights tab, and we want to make sure again all of our top heights are based on model top. So we'll do that. We'll look at our bottom height, which is set to our selected contour, which is what we want. We'll now go to the passes tab, and I usually break the edges by 10 to 15 thousandths. I'm going to go ahead and use 15 thousandths for my chamfer width. Now, an important thing to note here is if you modeled the chamfers when you created the model, so then you would need to put a 0 chamfer width, and Fusion 360 would be able to find the chamfer width for you from that model. But because I didn't model in the chamfers, and that's a sharp edge, I'm just going to go ahead and specify my chamfer width of 15 thousandths. I'm going to leave the tooltip offset at 40 thousandths. That's fine. So that's just Fusion bringing the chamfering tool past the tip by 40 thousandths, so we don't break the tip of our chamfer tool, especially if it comes to a fine point. The next thing is the chamfer clearance. So if I hover over it, this will give us clearance if we are chamfering next to some type of wall. In this case, since we are chamfering the edges of our wall, there's nothing beside the end mill to worry about, so we'll leave it at default. We'll go ahead and enable smoothing, and again, feed optimization. Now I'm going to go into the linking tab, and again here I'm just going to change the lead in angle to 45 degrees. Going to click OK. Alright, and so that is our completed toolpath. I'm going to right click and go simulate. And then we'll just watch the chamfer mill go around the inside and then the outside, leaving us with a smooth edge. So when we pick it up, we don't injure ourselves. All right, now we'll see this all performed on the Tormach. Thank you.